Okay, so this is problem 12 in the mechanics textbook, and we're going to go ahead and get through it. It's very similar to the previous problem, 1.111, which I think is the last video uploaded. It's in the playlist, so I'm sure you can find it. The only difference is there's a z component for this one. Everything else is exactly the same, which is nice. This makes this really easy. So I'm not going to repeat too much, but we know x is going to be equal to, or x component is going to be b cosine of omega t, or y component is going to be c sine omega t, and now with just the one additional addition, z is equal to v naught times t. Well, I don't want to go over the previous problem too much or going over the exact same steps, but we found that in the xy plane that x squared over b squared plus y squared over c squared is equal to 1. This is doing the little bit of algebra manipulation we did before. We got to this solution. You can watch the previous problem again if you're not sure how we got there. So, okay, we get this ellipse, but now you might ask, well, how does this z component compare? Well, let's think if we drew a picture. Let's draw just a little, nothing crazy, but, you know, we'll call this x, this y, this z. So if you imagine if we just had an xy plane, or let's switch these actually. We're not doing calc, are we? If we looked at just an xy plane, right, we got an ellipse. We got an ellipse, however it might have looked. But now we're adding this z component. So what's happening? Well, you have this ellipse, however it might look, and then with this z component, it's increasing by a rate of v naught for every unit of time. So what does that actually relate to? How does that actually relate to the shape? So you have this elliptical motion, just as we had previously, but as the particle's going around this little ellipse, it's advancing in the v direction at a velocity v naught. So basically, if you can imagine a cylinder and it's spreading out this direction, what are we going to have? What shape is that? Well, it's going to be kind of a weird looking shape, but you could imagine it'll look something like this, right? Where this part here is your ellipse, or I should say, where this part down here is your ellipse, and then it just keeps growing. It goes up and up and up at a rate v naught. So really not that much different than the other problem, only now we're adding another dimension. So hopefully why that's the case makes sense now. It's kind of weird to visualize, but basically you have an ellipse, and with each unit of time, you expand in the z direction by your time times your whatever v naught was, the constant. So that's how we get that shape.